Okay, so today, as you can see, I'm not here, and so I'm going to do a little video here for you on today's lesson. And this is actually something that we've already done in the past. We've already seen stoichiometry, right? Remember, stoichiometry is when we do calculations on chemical reactions. And so the first thing we need is that balanced chemical equation, right? And that allows us to get what is called the mole ratio. Now, the difference between the questions we're going to do today and what we've done in the past is that we're going to be using information that involves solutions, which means we're going to be using molarity, right? Remember, we've learned that molarity is the concentration we use as chemists because it tells us how many moles are in 1 liter of solution. So we can easily create our triangle from our units as we normally do: moles, molarity, capital M, and liters. We will also be working with questions that involve mass, and the equation we've learned in the past is molar mass. That's 2 capital M's, and its units is grams per mole. So when we use our molar mass calculations, we can generate our triangle there, and we can get molar mass, moles, and now we can then use our mole ratio like we did in the past to go between the moles. And so again, we'll have calculations that involve 3 steps, all right? So this lesson really isn't very long. It really is made up of 2 examples, and then you can work on homework, and there is also an assignment on Google Classroom that you can work on as well. Excuse me. So keep in mind, right, we need the balanced chemical equation. That's the most important thing that we start with. So once we have that, we're going to change the given information into moles using one of our equations, and then we can use our mole ratio from the balanced chemical equation. All right, so let's go ahead and do our couple of examples. Okay, so determine the mass of silver that would be produced from the reaction of 250 milliliters of 0.10 moles per liter silver nitrate solution with an excess of copper. So just as we did before, you're going to write the information that you're given in the appropriate line, and you're also then going to put a question mark for what we're trying to find. Determine the mass of silver. So silver, question mark, grams. We want to find grams of silver. So we put it in the grams line. Now, this line here at the top, remember I said that there were 2 lines, and we put moles in this line, and we use our mole ratio, and we put grams in this line, and we use our triangle. But now we've got a new measurement. When we're dealing with solutions, we're not given grams, but we're given milliliters. So milliliters and liters can go in there as well, all right? So let's write down what we have: 250 milliliters, and now we've got a concentration, all right? Now that concentration is very important. That concentration is really just like the molar mass, all right? So when we have a solution, I like to put the molar concentration, the molarity, capital M, and I like to write it right in line with the arrow, 0.10 moles per liter, all right? Because that's the thing that allows me to get moles. So I like to put the volume at the top, then the molarity in the middle, because that's what I use to get moles. Now, once we have moles here, we can go over that way, and we can convert it to X moles, and hopefully you remember we can use the mole ratio, and when we move up, we turn our moles into grams using our molar mass equation, which is grams per mole. Now, we also have to use our molarity equation. That molarity equation is moles per liter. So, again, we've got a 3-stepper. This time, we're going to convert our milliliters to moles using the molarity triangle. With the mole ratio, we're going to find how many moles of silver is produced. And then with the molar mass triangle, we're going to get grams of silver. So we need a molar mass. It's just silver, but I like to write it down off the side. Grabbing my little periodic table here, 107.9. 107.9 grams per mole. Excuse me. So now let's do our three calculations, starting with what we have, our molarity calculation first, then mole ratio, then molar mass. So in our triangle, right, we have moles on the top, molarity, and liters, and I need to find moles. Moles is equal to molarity times liters. The molarity, there's my concentration, 0.10 times, and now I need liters, 250, and remember, we can easily turn that into liters by using the prefix for milli minus 3. So 0.10 times 250, EE or EXP negative 3. I'm now calculating, so you got to give me a second. 0.1 times 250 EE, and that is negative 3 equals, and I get an answer of 0.025, and that's moles. All right, now I'm ready for the mole ratio. X over, right, my 0.025, I just calculated it, 0.025. My 5s aren't looking very good today. X over 0.25 is equal to 2 over 2. That's not very exciting, eh? 2 over 2. And our opposite operations calculation, right, brings that guy up to the top, right, where we can then multiply it. But it's 2 over 2. You're going to find that that cancels out. And so you're going to find that we have 0.025 moles of Ag, of silver, right? So now we've come across our mole ratio. Now I want to get grams using the molar mass in moles. And I'm wondering if we can, well, I'll make the triangle. We'll just make the triangle just so that we can see it. Grams, moles, molar mass. I apologize for squeezing that in there. We want grams, so molar mass times moles. Grams equals molar mass times moles, and that's equal to 107.9 times 0.025 and times 107.9. I didn't have to, well, anyway, yes, times 107.9 equals 2.6. And that's going to round to, that makes it ugly. I got to erase. It's 2.697, so that rounds to 2.70 grams Ag. All right, 2.70 grams Ag. All right. So what did we do here? Well, number one, we used molarity to find out how many moles. Then number two, we used the mole ratio to figure out how many moles of silver was produced. And then number three, we used the molar mass to figure out how many grams of silver was formed. So, like I said, this is just like regular stoichiometry, except now sometimes we may start with a milliliters and use the molarity, and we might end up having to find milliliters in a question, and hopefully we have to do that in the second one. So let's do the second one. Oops. Okay, so determine the volume of 0.55 moles per liter. Now, notice it says determine the volume. That means we're looking for question mark liters, okay? And notice it says of 0.55 moles per liter. Now remember, moles per liter is our unit for molarity. That means this is our molarity. This is our concentration. So that number right there is used in the calculation to get liters. So determine the volume of 0.55 moles per liter, Ki, that would be required to produce 2.5 grams of lead iodide. 2.5 grams. So that's the mass we want to produce, again in our gram line, 2.50 grams. And we want to find, as we stated here, how much potassium iodide, question mark, liters. Okay? Heading this way, we need a molar mass because that's how we convert mass to moles. So we'll need our grams per mole. Heading over here, mole ratio coming from our balanced chemical equation. That's going to get us our X moles. And then heading up here to get from moles to liters, remember we need a concentration, and I like to write that molarity right in there, 0.55 moles per liter. And our equation, molarity, is moles per liter, just like in the units. That's where it comes from. Excellent. So we're starting over here, going to need a molar mass, then heading over here. So let's get our molar mass. PbI2, and I is, oops, no, I thought it was chlorine, which is 35.5. Iodine is not 35.5, so I need to put my Pb back in here. Iodine, I better check my little table here. 126.9, 126.9, 0.9 times 2. This is going to be a heavy molecule. Lead is 207.2, 207.2. So 126.9 times 2 plus 207.2 equals 461 grams per mole. Heavy, heavy. So let's start with this guy. I don't care what side of the page. I guess we could work over here because it is on this side of the page. So we need our triangle. All right. Grams on the top, moles down here, molar mass. And this time I'm looking for moles. Moles are equal to grams over molar mass. And we have 2.50 grams. And we have a molar mass of 461, heavy guy. So 2.5 divided by 461 equals 0.00. These first two zeros are not significant digits. They're just making the number really small. 542 moles. All right. Now we're ready to head this way. X over, there's my number right there, I'll write it underneath it, 0.00542 moles. X over 0.00542 moles equals, X over that equals 2 over 1. 2 over 1. All right. Again, I'm going to bring this guy up here, law of opposite operations. 0.00542, and then it's going to be times 2 divided by 1. So that number times 2, I don't have to actually divide by 1, and I get 0.0108 moles, and that's a moles of Ki. Moles of Ki. All right? Okay, so now we've got our moles of Ki. We're ready now to find liters. Making our triangle out of this guy. Moles, liters, molarity. We want liters. Liters is equal to moles over molarity. Running out of room here, so I'll make a little squiggly line here so I don't run into the calculation. So moles, 0.0108 came from there, right? Moles of Ki, which is right in there. And the molarity, I've wrote down. There it is, 0.55 moles per liter. So if I take 0.0108 divided by 0.55 equals 0.0197 liters. And there is our final answer. All right? Now that's in liters, and you don't have to convert it, but if we move the decimal place over 3, 1, 2, 3, we get 19.7, and that turns it back into milliliters. All right, so it took 19.7 milliliters of this solution to produce 2.5 grams. Again, to stress, we're doing 3 steps. This time, we started with molar mass to get our moles. Then, in the number 2 spot, we converted those moles into moles of potassium iodide using the mole ratio. And our third calculation then used the molarity to find the number of liters of this solution that I would need. All right? So you can see there that this is very much the same as what we did in the past, except now we're using the molarity triangle. So work that you can do right now. There's a practice sheet online, all right? And there is also an assignment, all right, which is also assignment, all right, you get the idea, on Google Classroom. That's going to be collected. That's going to be due on Monday, I believe. And you can also look at the Unit 2 Part 2 review. I'll put it up on Google Classroom as well. And because we're heading into a test into the next week, all right? We're going to be doing a lab Monday and then review Tuesday, and I believe our test then is on Wednesday. All right, that's that. Now you can work away.